Intermolecular forces are the forces between two molecules. And intermolecular forces are always a result of forces of attraction. So this is a huge key point we need to know. Intermolecular forces are forces of attraction. So that means between oppositely charged particles. Negative and positives will be attracted. But what is different is how and where these charges come from. For example, we've talked about molecules like water that have dipole moments. And they have a dipole moment because oxygen is more electronegative than hydrogen, so it pulls electrons towards it. And since electrons have a negative charge, that gives the oxygen a negative charge and the hydrogen's a positive charge, resulting in a dipole moment towards the oxygen. So since there's this uneven distribution of charge, water is polar, which means if there's another molecule of water nearby that also has an uneven distribution of charge, these opposite charges are going to attract. Boom, boom, right here. There will be an attraction. And we know that this particular type of attraction is called a hydrogen bond. But it is just a specific type of bond interaction called a dipole-dipole interaction because it's between two molecules that have dipoles. There can also be interactions of attraction between two non-polar molecules, meaning molecules that don't have dipoles. But how does that occur? If there's no dipole, there's no negative and no positive charge. So where does the attraction come from? Well, these forces, which we're going to see in non-polar molecules, are called London dispersion forces. So this is a definition you need to know. Otherwise called induced dipoles. So London dispersion forces are, definition, forces of attraction between non-polar molecules as a result of uneven distribution of charge. That is temporary. So for example, let's look at this example here. We have helium. Two atoms of helium, helium A and helium B. Well, helium is it's an atom, it's non-polar, it's not an ion, but we know that helium has two electrons. And those two electrons are floating around helium, okay, around that atom. And again, we don't know at any given moment where those charges are going to be. Those electrons might be right where they are where I drew them, or they might both be on this side, or they might be both on that side. We don't know. They're all moving around very, very quickly. So at any given time, if we follow the arrow down, okay, those electrons could be anywhere. So let's assume over here in this diagram, let's say the electrons, those two electrons of helium, over on the left side. That means there's no electrons on the right side. So therefore, there's a slight negative charge on the left side of this atom and a slight positive charge on this right side. We would call this an instantaneous dipole because it's happening instantaneously. It's not happening between two molecules. It's one molecule, just the electrons have to be moving around, and at any given moment, they might both be on one side, giving this side a negative charge. So now this molecule is slightly polar. This atom, more particularly, is slightly polar, whereas back before, it was nonpolar because the distribution of charge was equal. Well, now what's going to happen if this helium atom has a slight positive charge over here? We know it's going to attract a negative charge. So that means the electrons that are floating around in helium, which are negatively charged, are going to be attracted and pulled towards the left side. So that means that if they get pulled over to the left side, that initial induced dipole, this instantaneous dipole on molecule A, on atom A, is going to cause an induced, meaning, temporary, caused by a dipole on atom B. because since there's this positive charge here, that's going to attract the negative charge from this side, so the electrons pull over, and if the electrons get over to the left, that means the left side is going to have a negative charge. So an induced dipole is a result of an instantaneous dipole happening on one atom, like here, which causes an induced dipole on the second atom. This can happen with molecules as well. So let's consider H2, hydrogen gas. Okay? Hydrogen gas, diatomic, H bonded H bonded H, two molecules. Hydrogen bonded to hydrogen, they have the same electronegativity, so this is a non-polar bond. The electrons are being distributed evenly. But again, since there's two electrons in this molecule, they're being shared between the atoms. They might be right down the middle, but they might be more towards this side, or they might be more towards this side. It just depends on any given moment. So let's just assume that at any small moment, the electrons get pulled over on the left side. They just happen to be on the left side. So that means that the left side is going to have a slight negative charge, and the right side is going to have this slight positive charge. So an instantaneous dipole on molecule A is formed. Well, same theory again. If there's a slight positive charge here, it's going to attract a negative charge over here. So the electrons are going to be temporarily pulled over to the left side, which is going to cause an induced dipole on molecule B. Again, the key thing here is an induced dipole is temporary, and it is caused by an instantaneous dipole on a different molecule, which is a result of electrons randomly moving around. Okay? We can't control when an instantaneous dipole occurs. We can't just make this happen in one molecule. But if it does happen, we know the effect it's going to have on a separate molecule. So these induced dipoles are called London dispersion forces, because the word dispersion basically means spread out. So this is saying there is a force as a result of electrons being spread out at any given time. What you need to be able to walk away with today is a definition of a London dispersion force, which is the same thing as an induced dipole. You need to know how an instantaneous dipole can cause an induced dipole on another molecule. And you need to know that these forces are temporary. They don't exist. Since this happens on nonpolar molecules, but it also happens on polar molecules. So water will also have London dispersion forces. Okay? But since it also has hydrogen bonds, it has two types of intermolecular forces, whereas a nonpolar molecule or atom like helium or hydrogen only has London dispersion forces. We'll talk in class about how these can change depending on the size and the shape of a molecule, but that's what you need to be able to walk away with today.